And we are recording. All right. So, y'all, 7.1 is an introduction to hypothesis testing. Okay. So, y'all, a hypothesis test is a process that uses sample statistics like means or proportions. We don't really do variance to test a claim about the value of the corresponding population parameter. All right, so let's take a look here. It says an example. So a car manufacturer advertises that the new hybrid car has a mean mileage of 50 miles a gallon. Hey, we all would want something, right? A car that gets really great mileage. Okay, to test this claim, a sample would be taken using what we've learned from previous sections. We can determine if the sample mean differs enough from the advertised mean so we can conclude if the advertisement was false or whatever, right? Okay, so y'all, in hypothesis testing, we're going to have two kinds of hypothesis. One of them is going to be something called a null hypothesis, and I got some notes for you right there, both of them, please. Uh, one of them is called a null hypothesis, and one's going to be called an alternate hypothesis, okay? So it says a statement about a population parameter is called a statistical hypothesis, and there's always going to be two. Like I said, the null hypothesis and the alternate, okay? So a null hypothesis, y'all, the little symbol that we use for null hypothesis is this H with a little zero kind of at the bottom. And in the null hypothesis, y'all, there has to be some kind of a statement of equality, meaning it's going to say like the average is, say we're testing shower heads, right? So every morning or every night or both, you take a shower, right? You don't like it when the water comes out like real peat, right? It's hardly coming out. You want some strong pressure on that shower, right? So we might say, hey, look, the average flow rate of the water coming out of that shower head is 3.5 gallons a minute. If it says it is, that means it is equal to, or you might want to say something like it is less than or equal to 3.5. But there has to be some kind of equality in the null hypothesis. Okay. The alternate hypothesis is what we call the complement of the null. And it says it must be true if HO is false and always contains a statement of strict inequality, meaning either bigger than, less than, or not equal to. Okay, so y'all, there's the formal way that you read H with a little zero and H with a little a says you can read it as H sub zero or H naught, and the HA, they read it H sub A. Y'all, every time I never call it H sub zero or H sub A. I call it the ho and the ha because it's easy for me to remember. Okay. So it says some possible hypotheses regarding claims about the mean mu are shown below. Regardless of which we assume you must or use, you must always assume u is equal to k in exampling the sampling distribution on the basis of assumption. Okay, so let's take a look here, y'all. In the null hypothesis, the null hypothesis, y'all, always has, the null hypothesis, y'all, always has the ho, okay? And the alternate is always going to be the ha. Now, what's going to be the difference between the two is that the ho and the ha are going to be opposites of each other, okay? So look, just to give you an example, let's see what this is saying. This is saying mu. Mu is the average. Mu is less than or equal to k. Well, if something is smaller than or equal to, the opposite would be it has to be bigger than. Does that make sense? So if I said that there is 12 ounces or less of water in my cup, then the alternate would be there has to be more than 12 ounces. Does that make sense? Okay. Same thing right here, y'all. Look, the ho says it is bigger than or equal to k. The ha says it is less than k. Okay. Again, the ho says it's equal to k. The opposite, it is not equal to k. Okay. So we're going to be able to figure out some of these things here. Okay. And I'm going to show you guys, I'm going to walk you through the process. Okay. To see how we're going to do these things. So the question here says, for the statement below, write the claim as a mathematical statement, state the null and alternative hypothesis, and identify which represents the claim. Okay, it says a laptop manufacturer claims that the mean life of the battery of a certain laptop is less than 3 hours. Okay, so the first thing I'm going to do here, y'all, when they're talking about the mean, that's when we use that little kind of funny looking U. And you can see the choices, they all have that kind of funny looking U, right? So my average battery life is what? Less than 3? Okay, this here, my friends, is what we call the claim. So I want you to look at the choices that we have, A through F. Which one of those says that the mean life of a certain battery laptop is less than 3? Which one of those, A, B, C, D, E, F? Which one do you think? E, right? So look, y'all, we're going to come back over here and we're going to pick E. Okay. Now, I want to point something out, y'all. Look, that was the claim. And you say, how do I know that that's a claim? Because it tells me right here, that's what they are claiming. That's what they're telling us, right? Okay, I know, guys, on your notes, it's probably the next page, but let's take a look at this, okay? Now, it says, choose the correct null and alternative hypothesis below. So, y'all, I'm going to try to keep everything sort of on the same page. I know I don't want y'all to have to go back and forth, but if we look, we chose E, right? So we said the claim was mu was less than 3, okay? Now, we need to figure out which one is the ho and which one is the ha, okay? So the ho and the ha. The ho, y'all, always has to have something where it says equals. I notice this does not have anything with equals. That is going to be my ha. So then what is my ho going to be? It's going to be mu. If this is saying this is less than, smaller, the ha, the opposite, y'all, bigger than or equal to 3. Okay, the opposite of my ha is going to be mu is bigger than or equal to 3. So look, y'all, now I'm going to come back over here. And I'm going to look at my choices again, A, B, C, D, E, and F. And I'm going to ask myself, okay, does one of those say the ho is mu is bigger than or equal to 3 and the ha is less than 3? Which one says that? Anybody know? C. So we're going to go right here, y'all. Boom. That's my C. Okay. All right. Let's keep scrolling down the list. Okay. Which one is the claim? So look, y'all, I'm going to come back up here. Look, we wrote it out. The claim was mu was less than 3. Mu less than 3. Was that my ho or was that my ha? That's my ha, right? So look, y'all agree D? Boom. And we got it. Does that make sense how we're figuring this out? So look, y'all, I'm trying to go really slow here. Question. Before today, had anybody ever heard of null hypothesis and alternative hypothesis? If you did, raise your hand. All right, so I'm the only one that knew about this, guys. And the only reason I'm the only one who knew about this is because I taught this class before and I took stats when I was in school, right? But this is something completely brand new, right? So when it's something is completely brand new, y'all, it takes a little time to figure things out. Now, I got a few more questions here, y'all. We're going to see if we can't figure this thing out, okay? What we want to do for these questions, y'all, we're going to write out the claim. We're going to identify both the null and the alternate hypothesis, okay? So, y'all, first thing I'm going to do, I'm just going to read through my sentence. Okay. The key word here, y'all, that I see is mean, okay? So look, the first thing is I'm going to write out my claim. And the reason I'm going to write my claim first, y'all, is because that's what the sentence is telling me. Okay, the mean weight of its contents of a 20-ounce cereal is more than 20 ounces. Okay, so they're saying, look, my average is more than 20. Okay, so y'all, just as a little sort of thing that you can do to kind of make things a little bit easier, ho has to have some kind of equality. Okay. Ha, no equality. Okay. So now here's my claim. So they say, look, we got a box of cereal. It's supposed to weigh 20 ounces. The cereal company is telling you, I know it says 20, but they're all more than 20. So is that my ho or is that my ha? That's going to be my ha, right? Because there's no equals there. Now, let's see if we can figure out what our ho is going to be. Y'all, the opposite of more would be what? Less than or equal to. Very good. Less than or equal to is going to be my ho. All right. So, y'all, one thing I always, and I'm glad that you said that right now. A lot of times when we say, what's the opposite of more? We're so quick to say, oh, it's less. It is less, but it's actually less than or equal to. So, on the same token, if I said, hey, what's the opposite of less? We would say not only more than, but more than or equal to. Okay. All right. Let's take a look at number 2. So, y'all, number 2 says a university publicizes that the proportion of its students who graduate in 4 years is 82%. Okay, I'm first going to write out my claim because that's what they're telling me. Okay, the proportion, y'all, the little symbol we use for proportion was that little p hat, that little p with a little triangle on top of it. Okay, because we're not talking about an average here. Okay, who graduate in 4 years is 0.42. Now, that p hat equals 0.42. Would you say that that is my ho, or would you say that's my ha? That's my ho. Boom. So then, let's go like this, y'all. Look, p hat, if it's equal to, the opposite of equal to, not equal to.
So on that, you always have to put the hat on top of it.
Yeah, and when you're doing this in my lab, it's going to be multiple choice. And in like the way we did the first question, guys, I'm going to scroll back real quick. The way we did the first question, where we had all those mu's, right? All the little funny looking u's. Instead of the funny looking u's, it's going to have the p hat, right? Very good. All right, let's take a look at number 3. Again, y'all, we'll go through it together. So again, the first thing I'm going to write out is my claim. Okay. So it says a realtor publicizes the proportion of homeowners who feel their house is too small is more than 24%. Okay. So they're saying my p hat more than is greater than 0.42. My question, my friends, is that my ho or is that my ha? That's my ha. There you go. So then our ho is going to be less than 0.40, less than or equal to, 0.42, right? So again, y'all, the difference between the null, which is the ho, and the alternate, which is a ha, is that they are opposites of each other, okay? All right, we got another one here. Number 4, it says a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so again, look, I'm going to come back here. My claim, the proportion of students is 61%. So they're saying my p hat is equal to 0.61. What do you think? Is that my ho or my ha? That's a ho. Okay, so look, y'all, let's write out the ha. If p hat is equal to 0.61, not equal to. Very good. Not equal to 0.61. Awesome, y'all. Doing great. Okay. Let's continue scrolling down the list, y'all. And we're going to talk a little bit about types of errors and something we call levels of significance. Okay, regarding which hypothesis is a claim, we're always going to begin a hypothesis test by assuming that the null hypothesis is true. Okay. A sample is then selected. When we perform the test, we're going to make one of 2 decisions. We're either going to reject the null hypothesis or we're going to fail to reject the null hypothesis. Okay, and it says, keep in mind, because we're only dealing with one sample, we might accept that one decision might be incorrect. And there's 2 types of errors here, okay? So look, y'all, it says a type 1 error occurs if the null hypothesis is rejected when it's true, and a type 2 error occurs if the null hypothesis is not rejected when it's false. We're gonna go into some details, but one way we can figure out hypothesis testing, y'all, is to compare it to the legal system that's used in the United States. Okay, so what happens? A carefully worded accusation is written. We suspect, or we're accusing Paulo of going to the Bank of America on the expressway and Cesar Chavez and going in there and demanding money that was not his, right? We're accusing him of that, right? I'm just picking on Paulo because he's right here. Now, y'all, in the legal system, Paulo is assumed innocent, right? At least in the United States. In other countries, you got to prove your innocence, right? But here, we're assuming he's innocent. It is up to the prosecution to prove without a reasonable doubt that he is guilty, right? So the burden of proof lies with prosecution. If the evidence is not strong enough, there's no conviction. That means they're going to say he's not guilty. It doesn't mean that we proved he's innocent. It just means that they could not prove that he did it. Does that make sense? The evidence needs to be conclusive beyond a reasonable doubt. Okay. And it says the system assumes that more harm is done by convicting an innocent type, which is a type 1 error, by not convicting the guilty type. Okay. So let's take a look here, y'all. Truth about the defendant. If Paulo was innocent, right? Suppose he's innocent and we voted not guilty, we would say, hey, justice was served. It wasn't him, right? He should not be held accountable. But if he was innocent, but he was found guilty, that's what we would call a type 1 error. In the legal system, y'all, we try to avoid that as much as possible. We do not want to send innocent people to prison. It happens, but we don't want to do that. This is the type of error, at least in the legal system, that we say this is a bigger problem. The other type of error is something we call a type 2 error. The type 2 error says, guess what? Paulo really did go in there and he really did say, stick him up, right? And really did take a whole bunch of money. But the verdict, the jury said, guess what? He's not guilty. That is a mistake, right? But it's less of a mistake than sending an innocent person to jail. Does that make sense? Okay. Now, y'all, what we're going to do here is we're going to figure out how to find a type 1 error and a type 2 error. Now, y'all, in the packet of notes that I gave you, I also gave you guys, let me come back this way, boom. I also gave you guys the little cheat sheet, right? I want you to do me a favor, y'all. Grab that other handout that I gave you. Grab the little cheat sheet, because what we're going to do, y'all, we're going to use that cheat sheet to figure out what type of error we have, okay? And I know it's in the notes right there too, y'all, but it's just, the little cheat sheet has it readily available. So let's take a look, y'all. We're going to come back over here. So look, we want to describe the type 1 error, okay? So look what it says. A furniture store claims that at least 70% of its new customers will return to buy their next piece of furniture. So guys, before I even try to figure out what type of error we're going to have, let's see if we can write out the claim. Okay, at least 70%. So y'all, we're talking about a proportion. So look, I'm going to use my little p hat. At least 70%. Y'all, using an inequality, how do you think I would write at least 70%? Do you think at least 70% means 0.70 or more or less than 0.70? What do you think at least means? Think about that for a minute. 0.70 or more, right? So look, y'all, or more would be 0.70. So y'all, if I told you, like, I'm 51, I don't have any biological kids of my own, right? And I'm probably not going to, because I'm 51. But suppose I said, you know what, at 51, I'm ready to be a papa, right? I want to be a grandpa, and I want to have at least 3 grandkids. That means if I've only got 1 grandkid, that's not good enough. If I got 2 grandkids, that's not good enough. I'm going to be happy once there's 3 or more. Does that make sense? Okay. So, yes, sir.
How did you know to put a P?
Because it's talking about a what? A percent, right? Okay. Now, This is my claim. Y'all, is this my hoe or is this my ha?
It's your home.
That's the hoe. Okay. All right. So let's take a look. Now, I'm going to come back, y'all, to my little cheat sheet over here. Okay. So look, we want to look for a type 1 error. A type 1 error says the hoe is true, but we're going to reject it. Okay. Let me come back to my notes. So this is my hoe, and this is true, but we're going to reject it. So look, y'all, it says a type 1. I got 4 choices here. I'm going to look at one that says this piece here is true. So look, the ones that would be true, the next piece of furniture is at least 70%. The next piece of furniture is at least 70%, right? Because that's what the claim is. That's my hoe, right? So I already know, y'all, I already know by process of elimination, it's not going to be B and it's not going to be D, right? Because we're looking for when the claim is true, okay? But it's true, but we're going to do what? We're going to reject it. Do you see that right here? A type 1 error occurs when HO is true, but we reject it. So look, y'all, I'm going to look at which one of those says it is at least 70%, but we reject it. Wouldn't that be choice A? Boom. That's how I'm going to use that little cheat sheet. Does that make sense? And how we use that little cheat sheet?
Can you show us again, sir?
Yes.
How did you do it? Just go one
So
step back.
so look, let's come back over here.
Yeah.
Look what it says. A type 1 error, right? Here's my type 1 error. It's going to occur when the HO is true, but we do what? Reject it, right? Okay. So look, this was the HO. This was true. So it has to be at least what? 70%, right? Because that's what they were claiming, right? But we're going to reject it, right?
So every time it's HO, it's always going to be true regardless.
Well, that's a type 1 error, right? That's a type 1 error. So now let's take a look. The next part says, can we find a type 2 error? Look, y'all, I'm going to come back to my cheat sheet. Let's take a look at where my type 2 error occurs. The type 2 error says, look, my HO is going to be false, but we're what? We're not going to reject it. Okay, so look, let me come back here. My HO is false. So if this here, y'all, if the greater than 0.70 is false, that means that it is not more than, but it is what? Less than 0.70, right? But let's come back here. Let's come back to our cheat sheet. Type 2 error, it's false, but we're going to what? Look at this part. What does this part say? We're not going to reject, right? Okay, so which is the one that says we do not reject? Fail to reject. Wouldn't that be in choice B, y'all? So boom, that's how I'm using that little cheat sheet. Okay. Y'all, that little cheat sheet's going to come in super handy. We're going to use it again on Thursday, guys, with 7.2. We're going to use it again next week with 7.3 and 7.4. So that's why I printed that thing out there for you guys, okay? Now, let me scroll down a little further down my list. Okay, let's take a look at this next one. Next question says, an urban planner, claims that the noontime mean traffic flow, okay, I see a word here I'm going to use, y'all. Oops, sorry. The word that I'm going to use here is mean, okay, is 34 cars per minute. So look, y'all, my claim is mu is equal to 34 cars per minute. Would you guys say that mu equals 34? Would you guys say that's my hoe or my ha? That's the hoe. Okay. So let's do this, y'all. Let's look again for the type 1 error. Guys, I'm going to come back to my cheat sheet. Okay. A type 1 error occurs when the HO is true, but we reject it. Okay. So let's come back. The mean time is 34 cars per minute, but we reject it. Does that look like choice A to you guys? Right? Look right here. Mean is 34, but we reject it, right? All right. Let's see what a type 2 error looks like. So look, guys, I'm going to come back. Sorry. I'm going to come back to my cheat sheet again. Type 2 error occurs when the HO is false, but we do not reject it. Okay, y'all, they're telling me this thing here is false. So if it is not equal to 34, I'm going to look over here. Look, y'all, C and D, those are the ones say it is not 34 beats per minute, 34 cars per minute, I'm sorry. But we're not going to reject the HO. So we failed to reject it. Boom. Doesn't it look like choice C? Right? That's how I'm using my little table, y'all. That's how we find the type 1 error and the type 2 error.
So why didn't you pick A and B? Just off.
Because let's come back here, right? If we're doing a type 2 error, look what it says. The HO is what? False, right? So remember what the HO was? The HO was that it was equal to 34. So look what these are saying.
Oh,
Right? So the HO is false. So we're going to look for the ones that say it's not equal to 34. Does that make sense? There you go. All right, guys, I think there's one more like this on the next page. All right, so let's take a look. It says, a police station publicizes that at least 50% of its applicants become police officers. Okay, look, y'all, we are talking about percentages, right? So look, my P hat, at least 50%. Doesn't that mean greater than or equal to 0.50, right? This is my claim, and that is the hoe, right? All right. Now, let's take a look here, y'all. Let's come back over here. We're going to look for a type 1 error again, okay? Type 1 error occurs when the hoe is true, but we reject it. Okay, so let's come back here. So the hoe being true says it is at least 50%, but we're going to do what again? We're going to reject it. Okay, so let's come back here. Which one says it is at least 50%, but we reject it? Wouldn't that be choice B? Okay. Now, I'm going to come back one more time, y'all. Let's take a look at type 2 error. Type 2 error says the hoe is false, but we do not reject it. Okay, so it is not at least. So remember what at least means, okay? At least means more than or equal to, right? So y'all, if at least means more than or equal to, which ones are not more than or equal to in less than, right? So wouldn't that be either choice, what, C or D, right? But then we're going to fail to reject it. Very good. So that is choice D. There you go. Yo, one of the things that I've noticed when I've taught this class before is like when I read through that sentence, it says it is at least 50%. Remember what that means, 50% or more. So then when I'm looking through the choices on my part 2, the type 2 error, people are saying like, hey, I don't see the at least anymore, right? I don't see that anymore. That's when you have to kind of understand that at least 50% means 50% or more. So then the opposite of that would be less than, right? So it's just like using those kind of terms. So y'all, this has, it doesn't have, I'll put it this way. Just again, so that you understand the idea here. Age. When we talk about older, I can't even write today. Sorry, y'all. Older and younger. Okay. Y'all, suppose I told you that I'm older than Paulo, right? If my age is older than Paulo's, wouldn't we say Omar's age is greater than, right? And if I'm older than him, then that mean, sorry, Paulo age, right? But see how we're using the terms like older and younger? And it's the same sort of idea, right? That when they say at least 50%, that means 50% or more. So the opposite would be less than, right? So it's sometimes it's those little terms that kind of throw people off. So just be careful as you're going through that, okay? All right. So now, question says, how do we know whether to reject a null hypothesis? This depends on whether you get an unusual sample, excuse me, an unusual sample statistic from the sampling distribution. We've seen unusual defined as less than a probability of 0.05. There's always a possibility that we're going to reject a null hypothesis that's actually true. To decrease this, we can lower the level of significance, okay? So y'all, in a hypothesis test, the level of significance, your maximum allowable probability of making a type 1 error is denoted by alpha. We're going to go get into some of that stuff, y'all, on Thursday, okay? Let's see, statistical tests and p-values. Okay, so it says, after stating the null and alternate hypothesis and specifying the level of significance, we're going to obtain a random sample and compute some kind of a sample statistic, either X bar or P hat. We don't really do the variance, y'all, so I'm going to skip that part, the S squared. Corresponding to the parameter. The sample statistic is what we call the test statistic. Let's see. With the assumption that the null hypothesis is true, the test statistic is converted to a standardized test statistic using either a Z or T score. I'm not going to do that funny looking X squared thing, okay, which will be used in making the final decision about the null hypothesis. Okay, so it says, if the null hypothesis is true, then a p-value of a hypothesis test is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Okay, so y'all, what we're going to do with this next piece is we are going to figure out, and we're going to do this, y'all, we're going to start doing like the actual testing with 7.2, 7.3, and 7.4. But we're going to talk about 3 types of hypothesis testing. One of them is called the left tail test, one is called a right tail test, and one is called a two-tail test. This all depends on the region indicated by the alternate hypothesis, my friends, which is what we call the HA. Okay, so I want you. I'm going to make this as easy breezy cover girl as I can. Okay, how do we know when we have a left tail test? We're going to look at the HA. Y'all, do me a favor. I just put it in the red box for you right up here. Look at the HA. Which way is the inequality symbol pointing? To the left. And por eso, in Spanish and in English, for that reason, that's why we call it a left tail test. It's going to be that easy. You're going to look at the HA and you're going to look at the direction of the inequality. Okay, take a look, y'all. Right tail test. Look at my HA. Which way is my inequality sign pointing? To the right. Boom. That's why we call it a right tail test. Now, the question is, hey, Omar, how do we know when we have a two-tail test? Okay, right here, y'all. Two-tail test is, if you look at my HA, do you see how the HA has not equal to? Not equal to, y'all, is going to be the outsides. That's when it's going to be a two-tail test, okay? All right, so for these next couple of questions, we're almost done, y'all, with 7.1, okay? So look, it says, for each claim, state the HO and the HA, and then let's figure out whether we have a left-tailed, right-tailed, or two-tailed test. And then it says, sketch a normal sampling distribution and shade the area for the p-value. Okay, so look, y'all, I'm going to walk you through the process. Let's do this. Number 1, let's list what our claim is, okay? Y'all, it's usually easy for me to first find my claim because reading the statement is going to tell me what they're claiming. Look, a water faucet manufacturer announces that the mean flow rate, so look, that's my mu, of a certain type of faucet is less than 2.5 gallons a minute, less than 2.5 gallons per minute. I got a question for you guys. Would you guys say that's my HO or my HA? That's the HA. Okay, so then do y'all agree that the HO would be bigger than or equal to 2.5? Okay. Okay, now we want to know left tail, right tail, two tail test. we're always going to look, y'all, not necessarily at the claim, but we're always going to look at the ha. The ha, look at the direction my arrow is pointing. Oh, it's pointing to the left. So look, y'all, we're going to do a little piece here to the left, and we're going to say, this is a left-tailed test. And that's going to be my P right there. And we're going to figure out what that probability is on Thursday, okay?
So is it safe to say that if we get a negative, it's going to be?
Well, it's, again, look at the direction of the arrow.
Yeah,
right?
Just pay attention.
Just pay attention to the arrow on the hop every single time. Yes, sir. Look, guys, let's do number 7. A cereal company advertises that the mean weight of its contents is of its 20-ounce cereal is actually more than 20. Okay, so I'm going to go like this. Claim. Okay. They're claiming that the mu is more than 20. Okay. Question. Would you say that's my ho or my ha? What do y'all think? More than 20. What do y'all think? Ha. Very good. That's my ha. Okay, so look, y'all. Mu less than or equal to 20, that's going to be the ho, right? Remember, you guys, we're always going to, to try to figure out what kind of test it is, we're always going to look at the ha. The ha says that arrow is pointing to the right. So I'm going to do a little piece over here. And I'm going to say that is a right-tailed test. Okay, boom. And we got that part done. Okay. Now, I'm going to scroll down a little further, y'all. And we're going to look at this next piece right here. Okay. And it says, a university publicizes that the proportion of its students who graduate in 4 years is 82%. Okay. So I'm going to write out my claim. My claim is that my P is 0.82. Okay. Guys, what do you think? Is that my ho or my ha? That's the ho. Okay. So then, not equal to 0.82, would you guys agree that's my ha? Okay. When it is not equal to, y'all, we're going to have these things, and this is going to be what we call a two-tailed test. Okay. And I'm going to grab, because I was working on my notes, y'all, I'm going to double check. And that is where we're going to stop, y'all. These questions here, I meant to take them out, and I didn't. But I want to show you guys something. Before we leave for the day, y'all, I want to show you guys something over here. Let me come back this way. Let me scroll down to my week 11. Let me go to my 7.1, y'all, because I want to show you guys something. With some of the questions, y'all, they're going to ask you, is it a left tail? Is it a right tail test? And we got to figure out some of those pieces. So look, I'm just going to pick out like question 15. I have no idea what 15 looks like. I mean, I did before, but I don't know what it looks like now. Okay. Let me just zoom in real quick, y'all, so you can see what we're looking at here. And it says, a brewery claims that the mean amount of beer in their bottles is at least 12 ounces. Determine whether the hypothesis test is left tail, right tail, or two tailed. Okay, so look, y'all, I'm going to do this real quick just to kind of show you what I'm talking about. Let me take this guy here. Let's copy it. Let's come back this way. I'm going to scroll over here, y'all, and I'm going to drop it like it's hot. Okay. Now, we want to know if this is left tail, right tail, two tailed. Okay, first thing I'm going to do, I'm going to look at this piece. First thing I'm going to do, I know they're not asking me to, but I'm going to write out the claim. At least 12 ounces. Does everybody agree that at least 12 ounces means more than or equal to 12? Okay. Question. Is that my ho or is that my ha? I'm sorry? That's the ho. Okay. Let's find the ha. What is the opposite of less, or I'm sorry, bigger than or equal to 12? Less than 12. Okay. Look right here, y'all. Which way is that arrow pointing? To the left. Boom, right? We're going to say it's a left tail test. We're going to come back over here. We're going to click left-tailed. We're going to go chickadee check, and we got it. Does that make sense? So notice they didn't ask me all the other questions that we kind of went through in the class, right? But I'm still writing out, my friends. I'm still writing out that part, so because I need to figure out which is the ho and which is the ha. Anytime I'm trying to figure out whether it's left tail, right tail, two-tailed, I got to look at the ha. Sound good? All right, guys, that is it for us today. Let me go ahead and stop recording over here. Boom, we'll stop it.